Hello, good evening. Thanks for stopping by. Welcome to the workbench. Now let me know how the music sounds, if it's too loud, if the microphone's too loud. It's all new setup, so if something doesn't sound right, let me know. Turn the music down a bit, okay? How's that? Because I don't want the music to be very loud, just enough to where you can barely hear it in the background. Alright. Thanks for stopping by, Dur. Alright, tonight we're going to work on a vintage guitar amplifier. This is a Kustom Sidewinder. The model's a 24C, and it was built in 1972, I believe, was the first production run of these. So early 70s amplifier. Let's see if I can switch cameras here. I've got the amplifier out of the cabinet. The cabinet's right here. So this is a pretty cool unit. It's got kind of a padded top construction on casters. Very neat. Has a big whopping 12-inch woofer in the back here. So I'm going to slide it back under here. I will need to plug the speaker in here after a while. And my cord's not quite long enough, so we'll have to just kind of make it work. Alright, so what this guy's doing, customer says that after it's warmed up for a while, if he's on stage playing, it starts getting a noise in it, kind of like a hissing noise, or best way to describe it would be like you're standing at the ocean, but it just gets louder and louder and louder and louder as the night goes on, as the amp gets hotter and hotter. So what we're going to try to do is figure out what is causing that issue and see if we can limit it down to if it's in the preamp, if it's in the effects loop, or if it is in the actual main amplifier. So we'll pull this top cover off here. And I've got most of the screws out of it already because I have pulled this cover off and took a peek in here earlier. So this is pretty cool because you've got the schematic right here. I don't know if you can see that, but with the light. But it is nice that they have the schematic included on this as well. So bear with me a minute. Oh, we're gonna plug it in. Thinking if we turn it maybe this way, y'all can still kind of see it, and hopefully I can plug in the speaker. Oh yeah, just barely. Alright, let me grab my guitar. We'll plug this guy in. We'll see how it sounds. See if we can get it to reproduce the problem that the customer is stating that it has. And we'll go from there. I'll be right back. go back a little bit.
It's been 11 years now. Mark.
Nice, and we've got ads on our background music. That's always fun.
You'll never forget.
The day I was arrested was the day I found out I was.
We'll just get rid of that for now. Okay, let's turn this guy on and see what it does. I'm not going to turn it up very loud. I'm going to blow you all away. Okay, so we're not going to have any reverb on it right now. I have the reverb tank disconnected. But we should still have tremolo. And we do. So speed is working on the tremolo, the intensity is working. We've got a vibrato as well on this amp. So that all appears to be working correctly. Okay, so all that section's working. It does have a little bit of a ground hum. I'll flip the position on the on switch. We'll see if that didn't really seem to help any though. Treble works. Pull for bright works. Middle works. Bass. Okay, right here I'm noticing a small issue. This right here is supposed to be your bass, and what it's actually doing, it's kind of acting like a second volume. So if I turn it down, put it in the middle, and this is all the way up. That's not supposed to be volume. That's supposed to be controlling the bass. So I know something screws going on right here for sure. Yeah, something weird's going on right here for sure. I'm not really hearing. Let me turn it up a little bit. I'm hearing the hum. I'm not really hearing anything else right now. turn that down, we'll unplug it, and get the guitar and get it out of the way. Ah, there it is. Okay, I hear what he's talking about now. I don't know how well you're going to be able to hear it, but that's full volume. There's no instruments plugged in. I'll be quiet for a minute, see if you can hear that hissing sound. So I suspect that hissing sound is what he's talking about. And I imagine as this guy warms up, as this amplifier warms up, that problem is going to get louder. So I'm gonna suspect that there's gonna be an issue in the preamplifier board, just based on the issue that we're seeing here with the bass knob. Yeah, see, I can turn this bass knob up and that makes the volume louder. That is not what that guy's supposed to do. Okay, what they're calling the middle, which is going to be your kind of mid-range sounds, that's kind of doing the same thing. And treble's definitely doing it as well. Okay, I think what we're going to do is we'll hook up a function generator to this. We'll run some tones through it, some test tones, maybe do a sweep on it. See if we can't get anything else to pop up. So let me grab another cord and I'll be right back. Alright, I think what we'll do before we run a signal into it, we'll just check some voltages. Let me try to turn this guy around backwards because I've got to have the speaker plugged in here. Hopefully y'all can see that. See if I can get y'all at a better angle. Well, there it goes. There, now it's working. Okay. Well, I don't know what that camera's doing. That camera's not very happy right now. We'll just use this one to see if we can get y'all in here a little bit. I don't know if you are going to be able to see the multimeter, but we'll work with it. What we got. Okay, I'm going to check our high voltage. Yes, ooh, wires. Lots of wires. I'm going to check our high voltage our rails, our positive and negative rail, and that's what's going to be our high voltage for running the power amplifier itself. And we'll see if we're good there. Okay, I've got, don't know if you can see that or not, but I got 45.3 volts on the positive rail. I'm sorry, that was the negative rail. Yes, negative rail 45.4 volts, positive rail 45.4. So our power rails are good and balanced. Our total power got about 90.8, so 91 volts. So that's looking good. I'm not seeing any imbalance there. Let's check our supply to the preamp board and the effects board. So across I've got 27.03 volts there, so that's looking good. We'll check our positive rail. Got 13.45 and the schematic called for 12, so we're good there. And negative rail is 13.59. So 13.4 and 13.6. That's not too bad. That's pretty close. So I'm not seeing an issue with our supply voltages going to the preamp board or the effects board. You recognize some of these wires? Okay. Trying to turn this so y'all can see it. Okay, there's definitely some noise coming through there, and like I said, it does appear to be getting louder the longer it just sits here idling. We'll run some tones through it, see what we get. Stay. Screwdriver rolling around. Okay, I'm gonna try not to blow y'all away. Normal wires, yeah. Normal wires. Okay, Okay, so that's about 200K, or 200K. Alright, this is probably going to get a little bit annoying. I won't do this for too long. Alright. So frequency response to me seems pretty good. There's not any dead spots or anything in the frequency spectrum or whatever. I'm just going to turn the amp back up. So no instruments plugged in, that is at full volume. And now I'm definitely hearing a distinguishable, like a tone, or not really a tone, but more of static hiss. It does sound like you're at the ocean, like the waves are crashing in on you. So that's not normal. We shouldn't hear anything. This thing should be dead quiet with no instruments plugged into it at all. So let me bring y'all in a little bit. So this section right here is the preamp board. We've got some pre-stage transistors right here. There's one here. There's one here. Then as it goes through your bass, mid-range, and treble, you add your stages. You got another one over here, another metal can transistor over here. I'm going to tap on them, see if we can get anything to change, any noise to change. Right now we're just trying to isolate where the noise is coming from. There is a microprocessor right here, and that is a Texas Instruments. Let me see if I can read the number on it. It's a 7241A, so that's a TI 7241A chip, and that is going to be a, I believe that's a digital oscillator chip. It's going to be let's count the pins. So it's a 14-pin chip, so that's going to be a quad channel. That's a 4-channel digital oscillator. This chip here could be bad. Let's say this amp is from the 70s. So this old silicon IC chips and transistors and whatnot are starting, they're going to start showing their age. And as they age, they're going to break down internally, and that will cause noise issues. It's either going to fail or it's just going to be very noisy, and and the hotter it gets, the longer this thing runs, the noisier it's going to get. So I'm not really getting any I'm not getting any response by tapping on them. This one right here seemed a little microphonic. But there is a ceramic capacitor right here. This guy right here next to it, the ceramic capacitor. I don't know if y'all can see that. So this ceramic capacitor right here, these are known to be microphonic as well. So I can hear a little bit of noise through the speaker when I'm tapping on that guy. I'm not too worried about it though. I'm more concerned with the transistors. So I can tell you, I do believe the issue is going to be in the preamp board right here. Now we can verify that. If I just take and unplug this connector right here, that's got my positive and negative rail power supply, which 12 volts on each rail, so 24 total. And then the blue wire right in here, the blue wire coming out is my signal out of this board, and it just runs right over into the effects board, which is over here. This whole section right here is for your effects, your reverb tank, the tremolo section, the vibrato section. All that is processed through this board right here. So our output from the preamp board is going to run directly over into our effects, and then come out of our effects and come back here into this board right here. Now this is our power board. What it's going to do, it's going to take the amplification from the preamp, is going to run into here, and this is going to amplify it even more. And it's going to run it out and come over to these two. Now this is, you can't see them because they're underneath the bottom of the chassis, but here's the top of them. These are our power transistors, and that's what's going to give us our power to drive the speaker. So this is the bad boy part of the amp right here. This is the muscles, you could say. It's what's responsible for driving the speaker, giving us that 100 watts of power that this thing puts out. So I think what we're going to do, as far as troubleshooting, if I can get this camera to cooperate with me here. There we go. I'm going to unplug. I'm going to turn everything down. I'm going to unplug this plug right here. Okay, now what we've done is we have taken the preamp out of the circuit. So if I turn these knobs here, nothing. No sound, nothing at all. Because this guy is not even in the circuit anymore. So what I can do is I can inject. And also, what's interesting is the noise is gone. So when I unplug this, essentially we've gone full volume. And I'm not hearing any more noise. It's dead quiet. I hear just a slight hum. A slight 60 hertz hum is all I'm hearing from the line. What I'm doing is on the back of this amp there's a power switch, and most of your guitar amplifiers will have two positions that the power switch can go in. The middle will be off. You can push it to the right, that will be on. You can push it to the left, that will be on. The reason they do that is for line noise. If you've got some interference or some noise on your AC line, whatever this guy's plugged into, you can flip the switch, and what that's going to do is reverse the polarity. It's going to switch your line and your neutral, and it's going to swap those back and forth depending on which way the switch is. So if you've got, say you turn it to the right, and you've got a 60 hertz hum, a low frequency hum, you could flip it the other way, and a lot of the times that will eliminate that problem. So what we're going to do, we're going to inject some frequencies into this blue wire right here. See, and if I touch it, you can hear, I don't know if you can hear that, but it's humming. It's picking up interference from me. I'm basically coupling the line, and you can hear the hum, but it's quiet. It's dead quiet. I'm not hearing that ocean noise or sounding like waves are crashing against rocks or something that I was hearing that when the preamp was plugged in. So let me grab some wires here. We will inject a tone into this. Now, what you've got to be aware of when you're doing something like this is there's no volume control on this amp anymore. We've eliminated the preamp, which had the volume control on it. So now anything that we inject into this line here is going to be at 100% volume, and this thing puts out about 100 watts of power. So if I injected a signal onto this, 100 watts of power coming out of this guy, it's going to be deafening. So what I'm going to do is take I've got a 3.3 megohm tapered volume pot right here, and this is basically just a volume knob. It's all this guy is. It's a 3.3 megohm volume knob, and what we will do is we will put this volume knob in series with the tone coming out of my frequency generator, and that way we don't blow our eardrums out when we turn this thing on, when we turn on the frequency generator. Okay, let me move you up a little bit. So maybe you can see, but you're not too close. I'll try to get you in the full shot here. How's that? Can y'all see what's going on right there, maybe? Give me just a second, I'll be right back. Alright, sorry about that. I was trying to see if that other camera angle would be any better for us, but it's really not. Okay. Okay, trying to figure out a good way to do this. Let me pull that out for now so that guy will quieten down. Okay, so there's only one line coming out of here, our signal out on this blue wire. So we're going to need to hook the function generator negative over here just to the chassis, because everything's referenced to the chassis on this amplifier. Let me get this other wire out of the way. Okay. So we're going to turn on our frequency generator. We'll turn it down to 194 is as low as it goes. I've got it on the 2K setting, 193. And I've got a lot of different wires right here. I don't have the best setup, but I'm trying to use this to probe down in here. So unfortunately, I'm going to be picking up a lot of hum just because I've got a long cable linked here. All these wires are acting as antennas, so I'm picking up a hum. But if we turn this volume up, there's our hum right there. There's our... Turn it down a little bit more. We'll do a sweep on it. Okay, so other than our hum from just the links of wire that I've got here, no, I'm not doing that with my mouth. No, that is a sweep function generator, and it's starting at a low frequency and sweeping the audio spectrum. So I think we've pretty much determined, like I said, other than the little bit of hum that was coming through all the wires that I had here, because like I said, none of these are shielded, and I'm tapping directly into the input of the amp at full volume. So I'm going to be picking up a lot of interferences through these wires. So that's what that hum was. But other than that, it's quiet. The amp's dead quiet right now. I'm not hearing any other kind of hissing or crackling or any other kind of noise that's out of the ordinary. So let me get these all back out of the way here. So I'm pretty certain that our issue is going to be something in that preamplifier board that is causing all this noise. So let me get y'all back down here again. And we will plug, make sure everything's turned down. And we'll plug the preamp board back in. I'm going to make double sure that this is going the right direction in, because this is on and hot. Okay, preamp board is plugged back in. We're going to turn everything up full volume. And if you can hear that, our noise is back. So we know just by that test right there that yes, it's definitely, the noise is coming from the preamp section. What I'm going to do now is I've got just some duster. And if you've ever played around with these, you turn it upside down, spray someone or whatever, it gets very, very cold. You can get frostbite by turning this upside down. So I wouldn't, don't do that. Don't do that to someone. I'm not recommending you doing that to someone. But we can use this to freeze. What I'm going to do is I'm going to spray this on these transistors, and it's going to rapidly drop the temperature of the transistor. Now sometimes, not all the time, but sometimes if you have a noisy transistor or a noisy IC chip, which is exactly what this is sounding like, sometimes if you freeze a transistor or a chip, the noise will either get a lot louder or it will go away. It doesn't work all the time, but we're going to try it and we'll see if it'll work this time. So there's that one. I'm not hearing any difference. This board is very, very microphonic. Okay, if y'all can hear that. There's what they call it's a capacitor. It's an orange drop or an orange dip capacitor. Let's see if I can get y'all in here to it. This guy right here. This guy's very microphonic. Now these orange dips, they don't typically become microphonic. So this may be a culprit right here that's causing some of the noise. It may be this capacitor right here. There's a brown dip right next to it. I'm tapping on it and it's not doing anything different. But if I tap on this orange dip right here, this orange drop, that guy's very noisy. This blue drop capacitor right here, it's not making any difference, but this orange one definitely is. I'm going to try to hit some of this freeze on this IC and we'll see if it makes any difference. So I'm just going through and tapping on different components. Yeah, that guy's very, very microphonic. There's another one over here. There's a brown dip right down in here. And he's kind of microphonic as well. I'm getting some noise out of it. Oh yeah. So I believe we found, just by that right there, I believe we found what our culprit is. These going to be these two capacitors right here. Not getting any change on the transistors, so I believe they're going to be okay. I think we've just got a couple capacitors that have gone microphonic on us. So I'm going to turn the tremolo all the way up. And we'll just go through our effects board. And we'll just do the tap test on the components in our effects board. And we'll see if anything else, might be causing an issue. I don't think it is because we didn't hear any other noise once we unplugged the preamp board. But I'm here, so we might as well do it. Not hearing anything else. Let's turn the vibrato up and the speed and the tremolo all the way up. So that's all maxed out right now. Alright, I'm not hearing anything else through the effects part of this amplifier, just those two microphonic capacitors here in the preamp section. So there you go. I think we pretty much got it narrowed down to that's going to be our issue. So I'll have to get the numbers off those two capacitors, see if I can get some on order. I don't have anything in stock right now. Well, I've got a few things in stock, but mostly for vacuum tube type equipment. So not anything that's going to be the correct value for solid state. So I'll have to jump on AliExpress or something. Show you other cool gadgets. What other cool gadgets would you like to see? I've got all kinds of stuff here in the shop. I don't really have anything that I can just get to real quick, but I've got some vacuum tube amplifiers. I'm trying to leave and I just got on. Yeah. Now, I basically wanted to just kind of do some diagnostics on this custom amp to see if we can figure out where the noise is coming from, and I feel pretty confident that we've narrowed it down to what the issue is on there. So that was my highlight for tonight. I'm not really sure what else I could throw on the workbench right at this second and show you. But I do have a lot more projects coming up in the future. I've just got to get them drug out and get parts and stuff ordered for them. Throw this back on here. I I have a project that I need to get back on. Let me do a little teaser. Let me throw one of these. I've got two of these amplifiers actually that I've had for, oh goodness, going on 2 years. I need, when I get this guy here repaired and finished, I'm debating on, what my next project would be. I think I might go ahead and jump back on these other two amplifiers just to get them finished. But yeah, let me show you a little teaser. Let me give me just a second. Let me get this one out of the way, and we'll grab one of these other amplifiers and we'll put it on the bench. I'll be right back. All right. So, these guys here. This is what I would consider in the audio world probably the Ferrari or Lamborghini of amplifiers. But surprisingly, a lot of the stuff I've got, well, I won't go into it. But this amplifier was built in the same time period, in the 70s, early 70s. About the same time period, I believe, as this custom amp that we're looking at. So this is all solid state, early transistorized circuits. But these are special. These are pretty rare to come across. And when you do come across them in working or fully restored condition, they're fetching a lot of money. I mean, people are paying upwards of $2,000, $3,000, $4,000 for these amplifiers. Just insane. But there you go. It's Macintosh. I mean, that says it all. Macintosh. If you know anything about, audio equipment, early audio equipment, Macintosh was up there. They were one of the leaders. Now, are they the best? I'm not really going to get into that, that argument. There's a lot of good amplifiers from that era. Pioneer put out some good stuff. Sansui put out some good stuff. But Macintosh, I guess if you're an audiophile, Macintosh was the equipment to have, back in the day. Now, I mean, Macintosh is still in business today. I mean, they still make high-end, good quality equipment. But all I can say about it is you better have some deep pockets if you're going to walk into somewhere and start buying Macintosh equipment. But these amplifiers, no, they do not belong to me, unfortunately. I wish that they were mine. I wish that I owned them, because I would love to have both of these amplifiers. This is a 250, so it is a stereo amplifier, and it puts out 50 watts per channel. So you can bridge this amplifier and get 100 watts per channel. So, I mean, you may be thinking 100 watts, doesn't seem like much, but it is pure, crystal clear sound. I mean, these guys would rock. So, two of these, running both of them in mono, you'd have 200 watt amp. What is it? It's an amplifier. It's an audio amplifier. So, let me swap the camera here, and we can take a closer look at it. So these were, like I said, this is 70s equipment. This is the amplifier, so this is what is going to make the sound. So Macintosh didn't focus a lot on, cosmetics per se on their actual amplifiers. They focused more on their cosmetics on their preamplifiers, which would be another piece of equipment that your turntable, your reel-to-reel tape player, AM, FM radio, that would be all hooked up to your preamplifier, and they make some really nice preamplifiers that had 70s are as old as me. Not quite, not quite. I was born in the 80s, so these are a little bit younger than me, but close. But yeah, their preamplifiers would have VU meters on them that would move back and forth. Fancy knobs, lights, really classy looking equipment. Their AM FM receivers and their preamplifier. But as far as just their actual amplifiers, very, very basic. I mean, you've got, if I can get you in here and look on it, there's not much to these really at all. You've got your volume for your left channel, volume for your right channel. There's a switch right here, stereo or mono. Like I said, if you wanted to take this is 50 watts per channel. So if you wanted to bridge it, which, tying both channels together to make one channel, you would hit mono. Now you've got 100 watts of power coming out. And right here, these are your speaker out terminals. Not nothing fancy at all. Just terminal strips for, you got your right and your left. Got a common 4 ohm tap, an 8 ohm tap, and a 16 ohm tap. That's going to be your speaker impedance. Your 4, 6, or 8 ohm, or 4, 8, or 16 ohms. They did have right here a jack to where if you purchased these came as a series or as a set, so you would purchase the amplifier, either one or two, or if you wanted one, or if you wanted one to run 250 watt channels, or if you wanted to buy two and bridge them and run two of them putting out 100 watts per channel, you would buy their preamplifier and their AM FM receiver. All that would plug together. So this port right here would be where the preamplifier would plug into. And I may have told you wrong on that. This is a 250 model. I think some of the earlier model ones had that. This is actually an output. So I lied to you. I'm sorry. I'll take it back. This is an output. So this would be where you could plug in, instead of using your strips here, your terminal strips, you could plug your speakers in right here. It's got a circuit breaker right here. So auxiliary outlet, so you could plug in another piece of equipment right here. And then here's your two inputs right here, RCA style inputs for right and left channel. So yes, these are monsters. I mean, these are beefy amplifiers. These would put out, like I said, 50 watts per channel or 100 watts ohmed, and it was like something like 0.03% total harmonic distortion. So at full volume output, 0.03, that's insane. You couldn't even hear the distortion in it at all. I mean, you can't hear 0.03. So that's incredible. I mean, the stuff that they build today, like you run down somewhere, big box store, and you buy a receiver, you're gonna hook up your big screen TV and your satellite or cable box into it, or your Blu-ray into it, and have surround sound. You're talking stuff's gonna put out 5%, 10% total harmonic distortion. So meaning you crank the volume up and it starts sounding like crap. It starts mumbling and jumbling and just sounding really nasty. That's distortion. So the better built an amplifier is, the lower distortion you're going to get. And Macintosh really took pride in that back in the day. They really did. These things were engineered, hand-built, precision pieces put together. Your transistors, resistors, capacitors, everything was precision equipment, precision parts. So pretty neat. You're not gonna find, you don't find quality like that today. It's 2021. You can't go down and, unless you want to spend $30,000-$40,000 on audio equipment, you're not gonna get audio equipment that's gonna sound like this did. So that's why a lot of this stuff, people that own it, they hang on to it. They want it fixed. Some people spend big bucks to get this, equipment repaired, because you can't just run out and buy this anymore. So, anyways, these will be. I've got, like I said, there's 2 of these. I've done a lot of work on these. Both of them have the same problems. The output transistors are shorted. Parts for these are extremely hard to find. Now I can get knockoffs, fake chips, fake, it says it's the same thing, but it's not. So finding original quality components to fix some of this equipment it's getting pretty difficult. So I've been looking, actually, for the last 2 years. I've been keeping my eyes open for transistors. I have located some. They are very, very pricey. Some of them are, anywhere from $80 to $100 a piece. And there's 8 power transistors in this one. So normally you don't replace just 1 or 2. You replace the full set. So we're looking at, it could be upwards of $800 to $1,000 to fix this. So, it is what it is. But like I said, $1,000 to fix this guy, and they're selling for $2, $3, $4 on up. I've seen them as high as $6,000 for one of these in restored condition. So, if you find the right person that wants it, then there's people out there that still want to buy them. There's people out there to pay good money for them, and you're not going to get the sound quality from anything else out there that's made, unless you go out and spend, like I said, $20,000, $30,000, $40,000. And I don't know about you, but I don't have that kind of money to be throwing around just to listen to some tunes. But anyways, so yeah, these will be coming up shortly after we get this custom amplifier built and out of the way. Here you go, Haley. This was the function generator right here. This guy right here was, I'll turn it on, you can see. I don't know if you can see it or not, but this is what's making the audio tones that we were putting into the amplifiers. Was not my mouth. I cannot do that with my mouth. So, alright, well, I appreciate y'all stopping by and hanging out. I hope you enjoyed it. Let me know, if there's anything I could improve on. How the volume sounded, how the mic sounded, cameras, blah, blah, blah. Let me know. we're gonna call this done. Thanks again, y'all. Appreciate it. Y'all have a good night. And we'll catch you next time.